Welcome everybody. What we're going to do is we're going to take a look at lesson 6.1 and 6.2, and the essential question for these lessons here is how can we use fraction bars to add and subtract fractions with unlike denominators. Let's take a look at some examples. Before we take a look at fractions with unlike denominators, let's take a look at two fractions and how we would model them if they had the same denominator. So what we have here is we have 3/5 plus 1/5. As we were doing in class, we'd always pull our one whole bar up to compare it, the fractions to. So what I would do is I would take 3/5 pieces to represent the first fraction, and then in order to figure out what 3/5 plus 1/5 would be, I would take that 1/5 that we added on, and then I could see here that if I have my 3/5 and I add my 1/5 to those 3/5, I have a total of 4/5. You add the numerators, the denominator doesn't change because you're not using new pieces. You still have the fifth pieces, therefore the sum of 3/5 plus 1/5 would be 4/5. But things change when you have two fractions that have different denominators. Let's take a look at that. Let's say, for example, we were adding 1/3 and 1/2 together, and we wanted to use our fraction bars here to represent that. I have my one whole bar out here to start out. So I have 1/3 that I'll pull out, place it right underneath the one whole, and what I'm going to do with that 1/3 is I'm going to add my 1/2 to that. Now, unlike the last problem that we saw, the denominators are different here. So what we need to do is we need to find fraction pieces that will equal the same length of 1/3 and 1/2 when they're added together. The trick that we showed you in class was we were figuring out common multiples of the denominator, of the two denominators of the fraction, the 3 and the 2, and a common multiple that they share is 6. So what we did was we could use 6 pieces here to represent the sum of 1/3 and 1/2. And if we take our 6 pieces, what we'll be able to see is that if we take 5/6 pieces, we can see that 5/6 pieces is equal to the same length of 1/3 and 1/2. Therefore, our answer of 1/3 plus 1/2 is going to equal 5/6. And that's how you would use fraction bars to represent a sum of two fractions. Let me show you another example. So here's the second example. So now what we have here is we have 3/4, and what we're going to do is we're going to take our 3 1/4 pieces to represent what 3/4 looks like, and with those 3/4 we are going to add 1/3 onto that 3/4. And what you could tell before we even add these together, we could tell that our sum is actually going to be larger than one whole. So we want to keep that in mind as we do this. So what we need to do is we need to take our pieces here, our fraction pieces, that would equal the same length of the 3/4 and the 1/3 combined together. And when we do that, what we do is we need to find that common multiple of the denominators, which really is the common denominator we call, of 4 and 3. So I know a common multiple that these two denominators share is 12. So what I'm going to do is I'm going to use my 12th pieces and figure out how many 12th pieces is equal to this length of 3/4 plus 1/3. Now when I take my 12th pieces, what I could see is I could see that I have now 13 twelfths that are equal to the same length as the 3/4 plus the 1/3. Now, what we do is when we have an improper fraction, what we need to do is we need to turn that improper fraction around into a mixed number. And what you can see here with the fraction bars, if I take my one whole bar and slide it over my 12th pieces, I could see that 12 twelfths is equal to that one whole. So in order to replace those 12 twelfths, I'm going to write one whole. And now that I have those 12/12ths replaced with 1 whole, I can see I have 1/12 that's left over here. Therefore, 13/12ths as a mixed number is 1 and 1/12. So that's how you would use your fraction pieces to show the sum of two fractions with different denominators. But now let's take a look at an example of subtracting these fractions. So now what you can see here with this example is you have 3/5 minus 1/2. So what we need to do is we need to find the difference between 3/4 and 1/2. So what we're going to do is we're going to use our fraction bars to represent 3/4, and instead of adding on the 1/2 with the 3/4, what we're going to do is we're going to take this 1/2 and we're going to place it underneath the 3/4. And essentially what we are doing is we are trying to find out what the difference between 3/4 and 1/2 is. And what we do at this point is what we did when we were adding the fractions. We need to find fraction pieces that would fit into that spot right there. This one seems pretty clear that if you take a fourth piece and fit it right here, it's going to be the same exact length as that missing spot. Therefore, our answer to 3/4 minus 1/2, the difference between those two fractions is 1/4, as demonstrated by the fraction bar right here. So this next example, we have 5/8 minus the 1/4, which you can see I already have the 5/8 set up here, and I have the 1/4 placed right underneath that. And what we're doing is we're going to figure out the difference between those two fractions right there. We need to figure out what would fit in this spot. And once again, we could find the common multiple of the denominators, meaning the common denominator here, which would be 8, and use those eighths pieces and slide them in. But the way it's lined up, we could see pretty clearly that the difference between 5/8 and 1/4 would be 3/8. If I slid my 3/8 pieces right into this spot, you could see that matches the difference between those two fractions. Therefore, the answer, the difference for 5/8 minus the 1/4, is going to equal 3/8. So that's how we use our fraction pieces to show sums or differences between fractions with unlike denominators.